So very quickly, a quick comparison between NoSQL and RDBMS, where we should use. So this is like more like a thumb rule. Again, everywhere we have to do on a case-to-case basis. But RDBMSs are very good if we have transactional complexity. As I mentioned earlier, if you have create a, let's say, a CRM system or a ERP system where a customer has orders and orders have order line items and so on, and you need to update them in the same way always, then RDBMS are the best. But if you need, the complexity is not so high, but on the other hand, scale and you need to handle large volumes of data, I think that's when NoSQL databases are very good. As I mentioned, we'll talk about a few jargon. So CAP theorem is very often thrown around, which CAP stands for consistency, availability, and partition tolerance. And what this theorem says is that in a distributed computer system, at any given time or in any given system, you can guarantee only 2 of these. So that's a simple theorem. You cannot achieve all the 3. So, for example, RDBMSs are very good with availability and consistency, but when partition comes, they are not so good. And Neo4j, by the way, are also somewhat on those lines. That is one of the limitations of graph databases. Whereas if you take Cassandra, they are very good in availability and partition, but probably not in consistency, and so on. So that is CAP theorem, one of the jargons you learned. The other is acid and base. This is another thing. Many of you may be familiar with acid, but because this is RDBMS, it is used in RDBMS, which refers to having transactional consistency, if you will. So atomicity, consistency, isolation, and durability. ACID, that's the acronym. And they came up with a similar acronym for NoSQL. What it means is that it doesn't provide consistency always, but eventual consistency. So they call it basically available soft state, eventual consistency. Now, don't know who came up with these, but these are again some of the jargons, and we need to be familiar with this. Some of the myths, I think there are just a few more slides, so we'll wind up the presentation and move into Q&A. The commonly held myth is that NoSQL databases are only for read-only purpose. They should be used. Not really. They can be used for writing as well. And other is that NoSQL databases are a part of Hadoop and always used with Hadoop. No, not really. They can be used without Hadoop as well. You can write a regular Java application and use NoSQL as your storage. And that the NoSQL databases do not have schema at all. As I mentioned, they have an implicit schema. So you don't need to create the schema in the beginning, and the schema is not rigid, but at the same time, they also have a certain amount of schema. So those are some of the myths. What are some of the disadvantages? So as I mentioned, these are not a solution to all problems. So there are certain disadvantages of NoSQL databases. They cannot handle complex joins. So you need to write in your code if you have to create joins across 2 tables or column families or something like that. You need to take care as a programmer in the code. And there is no support for intrinsic support for complex transactions where you need to take care of consistency and all those ACID properties, but you can write your code in such a way that all this is taken care. And similarly, constraint support is also not there. So what is the future? Is this the end of RDBMS? Definitely not. So what the future will be a combination. We will have applications which will have a combination of RDBMS and traditional databases and NoSQL databases. And that is known as polyglot persistence. That's another jargon. So where you use multiple databases or multiple types of databases, each for doing a certain activity, but in your overall system, you will have a combination of these databases. So that is called polyglot persistence. So quick recap. So what is NoSQL? It is not only SQL. So we still use, in some cases, as you have seen, we still use SQL commands and so on. It's not a solution for all problems. Yes, it is good for handling large volumes of data, especially unstructured data. And finally, RDBMS is definitely here to stay. They are not going anywhere. And last slide is on, as I promised, some of the jargon. So we have seen, you must have now got familiar with what is big data, Hadoop, NoSQL, acid and base properties, gap theorem, horizontal scalability, and polyglot persistence. All right, with that, we will move into the Q&A session. So,
thank you, Mohan, for the insightful presentation. Let's quickly take up the questions now. I request you to read out the questions and their answers so that all our users may listen to the insights.
Sure. So let me check the questions here. There seem to be quite a few.
There are overwhelming number of questions we are receiving.
Yes. So we will, I think logically we'll go as first in, first out. So I'll take up the first question. This is from